All right, everyone, we are back and we are on our third problem, to be thin or not. Metal cylindrical system, radius, length, thickness. Material is the red curve here. So described by the red curve behavior. So write out the full stress strain tensors, calculate these values at the point where the red curve fails. All right. So we need where the red curve fails. That's about 375 megapascals. Because we are not given any. Yeah, there's a couple ways we can solve for this problem. Excellent. What's the strain value of the strain gauge 1? And actually, that would be the hoop. So there's actually multiple ways that you can solve through this problem. Yeah, let's go ahead and start to solve for it. So multiple ways we can approach this, assuming that we are indeed a thin wall pressure vessel. Our hoop is going to be in the 2. Our longitudinal is going to be in the 3. So we can go ahead and start to solve for this problem. So I'm going to say that my radius is 35 times 10 to the minus 3. Length, thickness is equal to 0.8. Materials red curve. We're also told that actually y is equal to metal, so it's equal to 100 times 10 to the 9. We'll see our nu is equal to 0.3. So we can go ahead and solve for this problem here. So actually the materials red curve, with the red curve, I'm going to say red curve fails in terms of strain. Ignore stress. So we're going to ignore the stress values there. Actually, let's do this instead. Where it fails in terms of stress, not strain. Excellent. So ignore the strain values. So now we actually know our del P. So where is it going to fail? So we said so we basically need to solve that sig H. Let's say 375 times 10 to the 6. Ooh, actually, no. Sorry, excuse me. There are no units on that y-axis, so we actually have to solve for it there. That was a good problem, Dr. Stone. Because units are important. And if we don't have the units, then we have to solve for it. So we have this. Yeah. And let's say we know that it fails. Let's see. It will fail when EH equals what? About 0.31. So here we go. Let's go ahead and solve these. And let's just say solve EH. Actually, we can say solve EHN along EQ. So this is our del P. Once we have our del P defined, we know our sig H, we know our sig L, and those are all defined there. Fantastic. What will be the strain value in the one strain gauge? The one strain gauge is measured along EH, so it must be where it failed. Fantastic. Draw the factor. Let's delete this. So not correctly. So if it's pulling here, fracture diagram will go like this. Excellent. So let's go back. Claim the material to be von Mises criteria. Is this valid claim? Well, von Mises is definitely valid. Is this analysis actually? Actually, yes, it is. So it is valid. There's no numbers to calculate, so that's just a conceptual question. And then E, all right, I have initial crack size of this, surface tension of this, fracture toughness of this, will the material crack? All right, now we can go ahead and say, I'm going to say my K1C. K1C is equal to 23 times 10 to the 6th. Solve K1C, set that equal to sig H times square root pi times A. So at least this is how I want to solve it. I don't want to do surface tension because again we're metal, so it's not valid. So if I have a crack size of this or larger, oh yeah, we're for sure cracked. So it will not survive. Fantastic. Thanks. I'll see you in the next problem. Bye.